Live from Phoenix, it's Saturday Night TWiM. From ASMCUE, the Conference for Undergraduate Educators 2023 in Phoenix, this is TWiM. This week in microbiology, episode number 299. Today's November 18th, 2023. I'm Vincent Racaniello, and you're listening to the podcast that explores unseen life on Earth. Joining me today here in Phoenix, Arizona, Michelle Swanson.
Delighted to be here, especially with our audience. Thank you.
Petra Levin.
It's great to be here, and the energy is much more than in my office when we normally record, for sure.
And Michael Schmidt.
I brought you the rain.
We have two guests for your enjoyment today. We're going to talk to them about unusual ways of teaching microbiology to undergraduates. From Colorado State, Amaya, Costas, welcome to TWiM.
Thank you. I'm very happy to be here.
And from Illinois College, Gwendolyn Knapp, welcome to TWiM.
Hi.
Thanks all of you for coming. Hope you enjoy it. We're going to start by hearing a little bit about the histories of our participants. So maybe, Gwen, you could start by telling us how you got to where you are today.
Okay. So I am an assistant professor of biology at a primarily undergraduate institution, Illinois College. It's in central Illinois. And I did my graduate work at Texas A&M with Jim Hu. So my PhD is in biochemistry. And in Jim's lab, we actually never did real biochemistry or enzymology in our lab. We did genetic tools in E. coli, and I studied protein-protein interactions and how proteins recognize their partners. And so after that, I wanted to study what they actually did. And so I went into gene expression and Mycobacterium tuberculosis. And when my fellowship was over, I wanted to teach. And so I had a class that a bunch of postdocs had organized at SUNY Albany at Wadsworth Center. And we taught different bits and pieces of what we did in the lab to our graduate students, because they did not know how to do this or they did not know how to do that. And so when my fellowship was over, I started adjuncting, and I taught the babyest chemistry class, and that is where I cut my chops in trying to teach. And it was a disaster at a community college, and then I got better, and that's what I decided I wanted to do. And so I am from the Midwest. I took a job at a PUI, not Illinois College, but McMurray College. And I don't know if you know of McMurray, but around March 26th, it announced that it was closing of 2020. It was one of the first ones to go out. I had already lined a job up, but it didn't start till August 1st of 2020. So I sat in my house going, I hope I have a job, because schools were closing and it was kind of a stressful time outside of the pandemic. But I teach immunology and microbiology and virology. I'm teaching genetics. And basically wherever they say we need you to teach. And I think my training made me adaptable to be able to do a variety of things. And that's what you do at a PUI. You go where you need to.
Why did you go into science to begin with?
Richard Kuhn was my professor at Purdue, and I was in his virology class, and I said, this is kind of what I want to do. And he said, go apply to grad school. And there I went. Not really knowing what it was. I was a first-generation student, and my parents said, you will go to college. And so I was the dutiful older daughter, and I went to college. And then they said, well, what will you do now? You will get a job. And I said, I don't want a job. And so I went to grad school. And I sat with Dr. Kuhn one day, and he was like, I was like, this is what I want to do. And he said, do this. And I said, okay. And at Purdue, you can take your rejection letters. And my roommate was applying to med school, so we had a lot of rejection letters, and we went to the bar with them. You get free shots at Purdue, by the way, so with rejection letters. So
A free shot per rejection letter?
free shot per rejection. It was quite the
Okay.
busy time in March.
Gwen, I would absolutely put my career in the hands of Richard Kuhn. You're very lucky. He's great.
So he was a great mentor to have in my undergrad. So
Amaya, what's your story?
My story begins as an exchange student in a little town in Montana. 100 people. There were 17 of us in the high school. And I played basketball there. I think that's why I chose like New England as where I wanted to go as a 16-year-old. So I ended up there, and that's relevant because our basketball team did really well. So they asked me to come back another year. I was a junior, and you're 16. Sure, I'll come back, and we'll really beat that other 100 people town, and and we. So I came back, and I was a senior, and somebody passed away and left money to full ride stipend for going to college, and they were thinking of rural Montana. I don't think they had me in mind, but out of a class of 6, 3 of I was the valedictorian so I got the full ride, and I went to college, which is needed. My family, I come from a blue collar family. I mean, the fact that I even was an exchange student was really a fluke. So the domino went. So I went to a small school in Montana. They had no research, but I took a lot of biology and chemistry. I got hooked on science in 8th grade, the whole carbohydrates and proteins, and it just really made sense. So I was already into science before I went to college. That was my identity. So I went to college with already an identity. I am a biology student, and that was really, even though I didn't know what that meant. So I loved college. There was so much learning. Did not do any research, as I mentioned. I did art. I did choir. I did all these other things. But I wanted to do more. I loved academics, and the only experience I had was teaching. So that's when my teaching career got started. And I don't know what would have happened if there had been research at my institution, because I didn't have that to be inspired. So I was super amazingly honored to go to grad school at University of Illinois at Urbana-Champaign. And I worked, shout out to Stan Malloy, who's here, who's an amazing professor in the classroom and outside of the classroom, as they were all of my faculty there. So I went and worked with Bill Metcalf on phosphorus redox cycling, which I always say, everybody talks about the nitrogen cycle, and they talk about the sulfur cycle, and but actually bacteria also mediate a little bit of redox cycling in phosphorus. So that was really fun, and that was my first touch of research, and it was both terrifying and amazing. Like, it was, I'd like seminars on that one room. I just soaked it up. Like they would come. I just got this new data from my students, and I was like, oh my God, they just got their new data. So I did that, but another thing about me is that I was a new mom and a new wife when I started my schooling. So that was a lot of new things, new research, new mom, and I was like 22. That's a lot. When I look back, I'm like, wow, that's a lot on 22-year-old me. So I didn't get a chance to develop. I did not hang out with the other grad students. So again, that community there, I really didn't get that for a long time. I took some years off. I got a master's instead of a PhD, just because again there was a lot of new things, and it seems like that was a better way to go. And then I got a call from Bill Metcalf and said he was going to be teaching at the Marine Biological Laboratory. Would I want to go with him? And by then, I had been pushing kids on swings for 4 years. I was like, yes, get me out of here. So I did, and that was amazing. That's where I found actually my community finally of research, and I started seeing, hey, this is something where I belong, where I can do, hanging out with all kinds of scientists there. That was amazing. And that's where I met Don Bryant at Penn State, who's a huge influence in my life. And I said, hey, can I come to your lab? My youngest are in kindergarten. And he was like, yes. He, really welcoming. So we moved the kids to Pennsylvania. They said, what language do they speak there? And I got a PhD working with phototrophic bacteria and just really amazing experience. And again, I just remember having so much fun in the lab. And then the kids got to middle school and high school, so it was time to be settled so they could have, their chance to grow as well. So we came back to Montana. That's where my husband is from, and that's been kind of home. Yes. And while they did that, I did cartwheels. I would be an adjunct. I would do an instructor. I drove to the major campus in Bozeman to do a postdoc. I just did everything so they could still have that their home while I was further in my career. And that might seem crazy, and it was a little crazy, but I acquired so many skills that I'm using now with my job. I had a lot of teaching experience. I did a lot of the ASM outreach webinars about how to teach. So again, I kept myself like that, and I worked with John Peters at MSU at Montana State on nitrogen fixing bacteria. Youngest went to college. I got a job. So now I am actually at Colorado State Pueblo. I am in it's in southern Colorado. It's a regional state university. We are a Hispanic serving institution. It is such a great match. I just feel really at home there. And my students are always very thankful of what we do for them. I teach microbiology. I teach virology. I teach molecular labs, bioinformatics, and I also have a research lab with master's students and lots of undergrads. We really pride on giving them, they can join the lab on their first day of their first year, and they can come, and we have something for them.
So, Michelle, yesterday you went to a session where these two individuals talked about something you want to share, right?
Yes. And it's the reason that we're here at TWiM, under the leadership of Nancy Burry, who is here. They have an NSF grant to use TWiM podcasts as a way to introduce the primary literature to their undergraduate students, and they do it through group work, through filling out a template to annotate the podcasts and to identify fundamental concepts in microbiology that are taught in that particular episode. Also, what techniques were used, what was the gee whiz part of the story, and then the plan is to make a compilation of these summaries and make them available to the education community. But that is just the overview, and I would love to hear about your experience, because it's a team of 4.
Yeah, it's a team of 4, and Nancy and Becky are over there, and it wasn't until Thursday, that we met for the first time in the hotel. And Nancy had sent out a call for wanting to do this podcast annotation. May 6th, 2020 is when it was. And I went back and found the Facebook message that I had messaged her when we were doing this today. And it kind of came out of her desire to be able to use scientific literature in the classroom, but also have replacement for those internships that were lost during the pandemic shutdown. And we met over Zoom. So I think the fact that we have a paper and a grant and having never met shows that you can work from home and be productive. But the goal is to be able to generate these open access resources that we as educators can use in active learning accessibility in our classroom.
So maybe, Amaya, you can tell us how the process works, because we love this idea that we make something and people use it, right? So
yes.
We want to contribute. Tell us more.
Absolutely. So we use, so as instructors, we're always trying to incorporate primary literature in our courses. And that is difficult because we have to comb through, we have all these classes that we're teaching. We have to comb through papers and whatnot. And you guys have this podcast where you've sort of done some of the homework for us, right? You've come through papers and you've highlighted them, and so that's one thing. The second thing that you do is that you discuss them, which is really nice. You have conversations, so that really brings primary literature alive. And so something that our students, they don't go to conferences, or they might not be able to sit at the table with other, with people like you, and suddenly they are at the table with you. So we thought, why not make it even more accessible, right? Because there are all these TWiMs, and we have learning objectives that we have to meet in our courses and whatnot. Why can't we take our vocabulary and add it to your podcasts? So we talked about the ASM fundamental statements. Can we combine those? So the process works that we all do it a little different. You can have an internship. You can have students, let's say a team of 3, and they work with you, and they analyze one of the TWiMs. They'll listen to it as a group. They'll read the paper that is linked to the TWiM, and then they'll what we call annotate it. And that means incorporating our vocabulary of educators into the TWiM. How does this particular episode fit in with the things that we have to cover and that we want our students to master? And then with this grant, now we're going to turn those into a press book and make it widely available. Because we published, hey, you can do this with your students and get a few annotations. And it's a great experience for the students who are doing the annotation. But it's also a great resource for educators. So that with the grant, we're able to do that.
Yeah. The students are able to take ownership of it. There's a peer review process that they can do, so they come together as a consensus of what they really feel that paper or the podcast covered. And the product that they get ownership and they get authorship on that particular annotation. So that's something that they can take and talk to in grad school interviews or med school interviews or whatever their next step is. And that peer review, I think we've seen today, is very important for students to learn from each other in their groups. And they also identify a really interesting figure to them. And so you want to...
Mm-hmm. So that's the first benefit, to be part of this internship, to be an annotator. The students who participate in that, they get such a great benefit of being, going in depth.
Can you tell us a little about, because we were in your workshop yesterday, so you have this set up so that it appeals to students you have students at different levels plugged in at different stages of the process, it seemed. So the annotators are not your first year students, is that correct?
Exactly. So that if you're going to be an annotator and do this with your students, these are going to be students who've already taken microbiology, and they understand what concepts, how to translate our vocabulary and add them.
Yeah.
But
those capstone type classes or honors projects for the annotation.
But a second benefit, and this is why this is so great, is that once you have them annotated, then a second set of students can take advantage of that, because now you can use them in your class. Because again, we've added those tags, and now you can use them in class with your first year micro students.
You've augmented our podcast for us.
Exactly, to introduce. Yeah. So I actually use your podcasts just like that in my class, and it's just really fun. The first thing they have to do is listen to the podcast, and then after that, we read the paper and we analyze it. And the papers that you guys choose are really, really exciting, and fun for my students.
Well, that's our greatest challenge, is picking. We created a verb. It's called, is this paper going to be TWiMable? Can you make the science approachable for a listening audience? Because there are no figures. We have to, as Ronald
there
Reagan,
are figures. We
just can't show them to you.
Exactly.
And, so I try, when I'm picking papers, to look for open access, because I know some libraries don't subscribe to the same journals that our libraries subscribe to, and often I have to scrounge through interlibrary loan. And so we look at these things.
Just ask the author for the PDF. They'll send it to you. That's the key, right? Just email the author.
And that's where I was going with that. When in doubt, just shoot an email to the first author. and it'll show up in your inbox toot sweet.
But what makes a paper especially appealing to the students that you're teaching?
That's what I want to hear.
So I'll tell you about the ones I chose for this semester, since I have it fresh. And the first one I chose, I try not to have too many figures.
Yeah.
So I tried to choose papers that go with the curriculum. So we had covered quorum sensing, and you guys had a recent TWiM on quorum sensing, and also that is relevant for them. So, we tend to have a lot of biomedical sciences students, and this had to do with Pseudomonas aeruginosa and infections. And there's the hook. They're going to be, at the minimum, every student is going to understand the background and the relevance. That is, and then more, so that's kind of my criteria. That was first one. For the second one, and I'll go back, actually, it's nice to have few figures so they can go and deep dive on them. They can't do that. They get really overwhelmed on large papers with lots of techniques.
So no cell.
Yes. But the second one, I also chose one that it was an essay. Kind of showing students it's not all just primary literature. Scientists, we like to read things for fun, not just have to analyze. And it was a beautiful essay. Also went with I had discovered metabolism, and it was in the human milk oligosaccharides. So we talked about breaking those down, and it really I had students glowing because I go back. I'm like, how did you guys like the TWiM this time? And they really enjoyed. So kind of simple papers.
Is there some aspect of being a podcast that the students really like because it's different, it's a digital medium, it's modern? Does that play into it at all?
Well, there's also the accessibility issues with it. So it's not only the open resource, but it's letting students read it and then hear it. And so, putting that word or how that vocabulary sounds, it's a big issue in terms of, have I seen this word before, or have I, do I understand what this word is? And so for them to be able to interact with it in different ways, that's a good practice in education in multiple modes of modalities. So it's really helpful for them to hear it and read it and see the paper and hear someone else talk about it. One thing when I teach is, okay, explain it to your neighbor so that it's not just me telling them something. And for someone else to be able to explain it to them, that usually helps get it differently.
And hearing you guys talk, I'm the only microbiologist my students will meet. And hearing you guys talk about it, and they identify with your jokes. I had a student who really
They get our jokes.
It's really rewarding. The students who, I just like all my students. I can't pass all my students, and they're struggling, and we do a TWiM, and they come like, I really liked the jokes, and I really liked hearing these people, and so that to me that's really wonderful because we're exciting people about science that might not be able to get 90% or 80%, but heaven forbid, they can enjoy science. So the podcast really adds that extra dimension and brings more people into science.
Yeah, I think the aspect of it being a conversation really helps because it breaks up the intensity and the jokes and so forth, really makes it accessible for students.
Another feature that we've added that, because we're motivated by making it accessible, is to talk not about the senior author, but the first author, who's typically a student or a postdoc. And they have wonderful backgrounds. I send them an email, how did you get interested in science? Tell us about an exciting day for this particular project. What are your hobbies? What are your hopes for the future? And we just learn just really wonderful narratives from people from all different backgrounds from all over the world. And my hope is that our listeners might hear something that they can relate to and begin to think, hey, maybe this is something that I could pursue. Maybe they can recognize a piece of themselves in these science stories.
And one more thing I thought about for my virology class, which you guys helped me teach a third of the virology class with your TWiM. We featured one from a university. The author was from New Mexico, so I'm in southern Colorado, and that really spoke to the students. I'm like, this is a lab, not very far from here, that you could go and work in this really great project. So I think that kind of featuring different authors like that really helps.
Come alive for them.
the science becomes approachable for everyone. They don't see it as this ivory tower. They say, I can do this, and it's possible, especially once they begin to see that they understand why the experiments were done. I think it's the why the experiments were done. And of course, we often don't get talked too much about all the controls that were done because we don't have the time in the only hour that we have.
Well, you only have two best friends in science, and those are your positive and your negative controls.
That is true.
And
Write that truism down. Your two best friends are your positive and negative controls.
And that is my PI, Jim Hoot quote. But that's one thing that I look for is, do they have a good control? Because as my students, they may not have the breadth of microbiology courses, so we don't have a micro major, but I want them to think about science critically. And without those controls, you can't look at science. And so I usually make them identify what is the control and why are we doing this before we even look at any other figure data. And often I'll clip it. I'll clip the gel or clip this and make them explain, what those controls are. And then they can go into the paper and delve.
Jim would be very proud.
So you've used this for microbiology teaching and also virology, you said. Do you use it in your virology course as well?
I've taught virology once, and I think we can all agree that first pass is a survival pass. But thank you for recording your lectures and giving me a guide on how to teach.
So, we have a lot of different podcasts, as you can see from the poster behind you. So presumably any of these could be used in different courses. We have parasitism, right? Any parasitologists here? Do you use?
We got one.
Yeah.
Maggie Schlarman, Washington University.
You should use TWiP, right? That would be fun. And
I use TWiM in my virology class.
TWiP, okay, very good. Anybody else in the audience use these podcasts? Yeah, a lot
We
of
have
people
quite
do.
a few.
So
Excellent.
good. So
In immune, we have one for immune.
Really? Oh, that's good.
The plan is the first phase of the grant is microbiology, because that seemed like low-hanging fruit. When you know your subject, and then our goal is to expand it and we call it the pair TWIX, and that X being every last letter.
Your template is you could use your template. They have this very nice template about, put the title, put where, if they only listed a section, where that section is discussed on the podcast, what's your favorite part, what's your favorite figure. And so you could easily use this for any of the podcasts, and probably not even only our podcast. Yeah.
So
and
if you
searchable
weren't-
by the fundamental statements, too. So
And-
depending on what you're teaching that week.
Yeah, and science and change.
So if you weren't at the workshop yesterday, can you get access to your template?
Yes. So we will you can email us. We'll send you the link to the annotated ones that we've done. There's 20, maybe? or
There's
so
20.
that are done. And our goal is to have an open access press book that we can share, and students will have authorship as well as faculty. So those of you who are at PUIs and need scholarship but have no money to do scholarship in that little circle where your primary goal is teaching, it's an excellent way to get authorship and get those RTP points.
And we are looking to broaden the community. We are definitely wanting to hear from you. And if you want to join us, part of the grant is to not just be us, but more of you helping annotate and being part of this community and bringing more lesson plans and more of your insights into this project.
So let's ask the audience a question. Which one, once they get micro fully baked, which one should they go to next that would help you out the most? Should it be parasitology, immunology, virology? TWiM.
Mm-hmm. And by the way, part of the project is to provide transcripts for all of the podcasts, because those were really nice for the older podcasts, and now that there are no transcripts, but we want to make sure that that's accessible and that students can have a handout or somewhere to read. So
Maya, you mentioned this this one TWiV where we talked about research done in New Mexico as a way of making it more accessible, more diverse to other people. So what could we do on TWiM and the other podcasts to do that? Make them more accessible, make it more inclusive, so many people feel that it relates to them. Not just TWiM, but any of the podcasts, obviously.
Yes.
Right?
So right now, as you know, I think researchers feel very identified. Right. This is a research podcast. So I think even bringing guests that would be interested, like in an allied health. You know, a lot of our students are allied health students, and we're always trying to, tell them you need to care about this. This is important for you as well. So maybe bringing people from from those communities to have a discussion. We actually asked our colleagues here, and having an undergrad student be part of your panel to discuss a paper, not as a guest, but as a panelist once in a while, so they can voice. They can have a voice. So and just your diversity of topics and scientists that you feature, of course. I think that is really nice.
I think it's one thing about teaching now. Students want to know why they have to be in this class. Why am I here? I don't know. You signed up. You tell me.
You have to answer what's in it for me.
Right.
And that's what they're really asking.
And so, basic research, not all my students are going to go to basic research. They're not going to go to grad school. They want to be pre-meds. I have students who come from counties that have no doctors, and they want to go back and do rural health. And so what they want to know is, how does this apply to their life? How does this basic science apply to a patient they might treat, or a drug they might prescribe, or, why do I care? Why? How will this affect my life? And I think students in this generation are asking that more frequently of, why do I have to know this?
Yeah, college is so expensive now. We really have to justify
Value-driven.
Value-driven.
Yes.
choices.
They do not take because for an answer anymore.
Because I said so.
But you know what? We had a beautiful session this morning about how to share our personal identity with our students and how impactful that is for them. So maybe that when you have guests, or you could ask them to share something about themselves so that students can identify with somebody. Again, your different personalities come through on the podcast. And
Certainly when we interview or just profile the first authors, we try to bring some of that in.
Exactly. And they can identify with the different scientists.
On This Week in Neuroscience, one of our panelists has a neurological problem, and she talked about it, and it resonated with people who said, I want more of that because I have that. And so that's how you get people to identify with what you're talking about, for sure.
Well, that was the take-home message from this morning's plenary session. They resonate and they identify, and it makes you, the faculty, more approachable.
I tell my students that at Purdue, I was not the best student. The first year I thought I was going to go to med school. And when you're never had calculus and you're in engineering calculus with 6,000 to 8,000 other people, you just kind of go, and I was average, but C is for commencement at that point. And they go, oh, you got a C, but you're still here. Yeah, because your grades matter, but they're not who you are. It's how you grow and how you take ownership of your education to figure it out.
So I understand you guys have questions for us about TWiM, so now's your chance.
So we took a survey at our workshop, and most people want to know how you started. How did TWiM start, and how did it evolve into
all of this
other podcasts?
So the first podcast was TWiV, because I am a virologist, and in 2008 I thought we should do I started listening to podcasts. I thought it was a good medium to disseminate information. I just finished co-authoring a textbook. So I got Dixon Despommier to start it with me. I didn't think anyone would listen. It was an experiment. It's what we do, right, as scientists. I figured you have a good chance of failing. But it worked. People started to listen. I said, okay. Then the second one we did was This Week in Parasitism, because Dixon was a parasitologist, and people listened to that. And by that time, we had been working with ASM to help promote the podcast, and they said, well, why don't you do a microbiology podcast? And so that's how TWiM got started. I think, Michael Schmidt, you were on with me originally.
I was number
right?
one with you, and another co-host is in the audience with us, Dr. Stan Malloy.
Dan Malloy was on that first episode, and we had a variety of people over the years. We had Joe Handelsman, Margaret McFull-Nye, Ron Atlas came once, and so then
And don't forget Cliff Mintz.
Cliff Mintz came, and then we just settled into this current makeup. Although Elio Schechter was on for many years.
But Elio was our driving force. Many of you are familiar with Elio's blog, Small Things Considered. If you haven't discovered it, discover it. And if you ever get asked to write a post for him, do it. Because it's 1,000 words, and it's the most powerful piece of literature you'll ever write, because he'll edit you to death. But it will be your best writing ever. And that's the standard Elio held us to.
So Elio was not on originally.
No, he
but
came.
I think it may have been Stanley who said, you need to get Elio on
Yeah.
TWiM. So I asked him, and he said, no, I have other things to do. And it took about a year for him to get on. And then he really helped us to go into deep depths. And he left us last year, and Petra has come on. And so that's how we got to where we are today on TWiM.
I'd like to add why I decided to join. I was invited to be a guest at a conference, and apparently I did well, so they asked if I'd like to join. And when I thought about it, number one, we rely on taxpayers' dollars to fund a lot of our science. And so this seems to me like this is a chance for us to give back and to reinforce the value of science to everyone. But also, as a woman in science, I know that, as you all do, the caricature of a science is a white guy in a white coat, right? So I felt it was really important that everybody recognized they have a place in science. So I wanted to be, add a woman's voice, but also then highlight the first author, because that added some diversity. So those were my motivations for joining the team, and I'm really grateful, and I'm especially inspired by your work to annotate and use these as a way to teach students and to introduce the scientific literature. I think that's a great way to grow our field. So thank you so much.
Yeah. No, I mean, I think the reason I'm doing this in part is because I really believe strongly in science communication. I have at least one of my former students in here, so she can tell you if I do this when I teach. But I think, as scientists, research scientists, my PhD advisor would tell us, if you don't understand a talk, it's not your fault, it's the person giving the talk's fault. And that's kind of, I think, what we're trying to do. We're trying to take papers, some of which are really actually clear, and some of which aren't so clear, and make them, a way that everybody can understand, even the undergrads who haven't really had micro understand them. And I think, for me, that's a challenge, but it's also our job. Like Michelle said, we're funded publicly, and our job is to give back to the public. And some of our work is esoteric, but in this way, we think that we can help everybody learn more and also maybe appreciate SciComm.
So we have other podcasts. We have Immune. We have This Week in Evolution. We have This Week in Neuroscience. We have Infectious Disease Puzzcast. We have Beyond the Noise. We have Matters Microbial. Is it Office Hours? And on each one, TWiVO, I'm lucky to have recruited similar scientists who give their time. I'm really grateful to them to do that.
Speaking of giving your time, Vincent,
yes.
in a typical week, how many hours are you podcasting?
I think the microbiologists have a term for that. It's called TNTC.
Yeah, that's good. Very good. All right. I like that. Good answer. Any other questions?
Vincent is too modest.
Another question that came up is, how do you choose your papers? How do you choose the topic that you're going to cover, and how do you...
What is the scientific method?
Yes.
So it's interesting. It varies by podcast. So since we're here on TWiM, everyone nominates a paper from week to week, depending on if they have time or not to do it. They'll email us at the beginning of the week. I think this would be interesting. And sometimes we shoot it down into, it's not very interesting, or not.
Most of mine.
It's not broadly relevant. people are not interested in dotting the I's and crossing the T's, right? The general population out there, you may be, but you want papers that say something that can mean something for them. So that's what we look for. So
Yeah.
TWiM is, a few other podcasts are like TWiM in that we all share picking. So we have a snippet, which Elio introduced, which is supposed to be 10 to 15 minutes. And Michael's snippets are an hour, of course.
This is where I get in trouble.
And then the
Is
main
that a
papers.
snap it?
Snap it.
Snap it. Yes, it's a snap it.
Anyway. So, but on the other podcasts, like on TWiV, I generally pick all the papers myself. So if you don't like them, you can blame me. And on the other podcasts, it's usually a mix of the two. So that's how we do it. Yeah.
I often read about interesting biology stories in the popular press, the New York Times, for example, and I'll look to see those papers. Also, I'm on Twitter, and I see people posting their exciting science, so that's sometimes a source of ideas for me. Or I hear a seminar, and I want to follow it up. But I also love it when we hear from you all what papers you'd like us to discuss, because we're sitting really looking at our screens, and we don't have a good sense for who our audience is, so it really helps.
TWiM,
to hear from you.
TWIM, at microbe.tv. You can send us your suggestions. If you don't like something, you can. We like it. If you don't like it too, it's fine. Just write and we'll fix it. Any others?
I think that was we covered the past, the present, and the other questions were about the future. Do you guys, is there like an intentional direction with your podcast that you're going to? You started with TWiV, and now you have all these other TWICs. What's
so
the plan?
in terms of TWiM, I think Michelle made a good point. We would like to get more first authors actually on the program to talk about their work.
Yes.
I think that would really
That would be
help
great.
to make people, like a graduate student, hey, look, there's a grad student on TWiM. I could do this. So we need to do more of that. It's technically a little more challenging to have guests every week because of equipment and so forth, but we can do it, and I'd really like to do that for TWiM and all the other podcasts as well.
So if you have any students that have a really terrific TWiMable paper, throw it over the transom to us and we'll coordinate, because you're the audience. We respond to you.
Now, in the broader sense, so this company, Microbe TV, is a nonprofit that I founded a couple of years ago to oversee the production of science, science programs for everyone, science shows for everyone. And then the subtext is education should be free. I strongly believe that. I really do. And I know you guys need to be paid, but there's another way to figure out how to do that, right? You don't have to charge for it. And so I want to grow this company to be a premier science communication company that speaks to everybody at different levels. So we do an hour of deep conversation. That's not for everybody. I want to do little videos that explain things. So for example, the other day at the incubator, which is the name of our studio, I was sitting there with Kim, one of our workers, and she said, Vincent, what's a beta-lactamase? And I said, turn on your iPhone. And she recorded a little video where I explained it. I love doing stuff like that. And I think we're the ones that can do that, and we can do it more and more. So I want to try all kinds of things that address different levels of understanding.
Those are things that we need as we try and implement a flipped classroom.
Yes.
Because there's so much, and I call it the transition state of moving towards that pedagogical adaptations. There's so much energy that has to go and find it, and the pandemic kind of taught us that we need to do that. We need to shift our education and how we teach, but it's also so energy consuming that when we have those readily accessible activities or videos or good quality videos that have been produced in a way that has transcriptions and are accessible and could download and put into a LIMS and all that, and students can just watch this quick little thing. I mean, they are the TikTok generation.
And students can create excellent content with your guidance.
Yep.
All right, we have 6 minutes left. Let's ask a couple of rapid questions of you. So what are some of the biggest challenges in keeping undergraduates interested in science?
For me, my students have a job, they have families. So for me in class, it is keeping the time. I have 50 minutes to to get them focused on science. They don't come, a lot of them don't come prepared. A lot of students knew they were going to be pre-meds in 8th grade, and they've taken AP Bio, AP Chemistry, and they come. A lot of them don't have the math, don't have the chemistry. So that's pretty challenging, because they need to have those. And so one thing that we do, as I mentioned earlier, we put them in the lab on day one. You might not be taking bio one, college bio yet, you're taking the math, but you can do PCR, you can do, grow your bacteria. There's a lot of things that somebody that doesn't have all this language, yet can actually contribute to science. So that's how we've addressed it at CSU Pueblo, getting, other skills. But that's a barrier, because at the end of the day, it does take them a lot of years, and some of them decide maybe a different major might be okay. So I think, the lack of preparation, I think, would be one of the challenges for us.
I think probably teaching them how to think like a scientist can be difficult because they've never been challenged or pushed that far. And in high school, if they've had to think really hard and it hurt their brain, as mine tell me, they stop, right? So that resiliency and to keep pushing, and it's okay to be uncomfortable with trying to think about something new, but you will survive this, and I'm here to help you get to that point.
Build those muscles.
Build those muscles. And I have open book, open note exams, and they are allowed to come talk to me. And they're like, what? And I said, come talk to me. I'd rather have a conversation about this question and make sure you get it. And I will help you if I can, and I will not help you if I can't. But I won't give you the answer. And I want you to be resourceful. The answer is somewhere in there. It's just not the bacteria was green, right? Why is the bacteria green? So.
Yeah, I just wanted to add that, I think we have emphasized a set of skills that was, can you recall concepts for so long? And those thinking skills that Gwen was talking about, or those experiential skills that we're using, that's really keeping and bringing people to STEM, because there was this really narrow litmus test that are you a textbook person, and I think now opening it up to, can you be curious? You don't have to know the vocab to be curious. And I wonder about this. Can you be critical thinker? And again, can you hold a pipette and, follow directions and get excited about what you get? And so I think that's really fun to see how a lot of people are now scientists.
Well, there was a truism: if you could make lasagna, you could do molecular biology.
Ours was baked bread. Yeah. We had bread baking contest in grad school.
Yeah. So you may not know what beta-lactamase is, but you are a scientist, right? You're being part of science and you're contributing. So.
Well, I think that was an interesting question, because I thought everyone knew what a beta-lactamase is, but obviously not. And I'm a virologist.
That's not making it very accessible.
No, I understand, but that's what that question opened my eyes to, and actually I know this. You should always assume that people don't know the answers and explain everything really well. Right?
They come from a diverse background and they know a lot about something, but not so much about that.
I got it. All right. Anything else from our two guests? We have to close now.
I just want to thank everyone who is here at ASMCUE, because you have been my mentors on how to teach, as well as the panel up here on how to explain science. So.
All right. That is TWiM 299. Show notes you can find at microbe.tv/TWiM. If you like our work, consider supporting us. We are a 501c3 nonprofit. Your deductions are federal, U.S. tax deductible. Microbe.tv/contribute. You can send questions and comments to twim@microbe.tv. Our guest today, Amaya, Costas, Colorado State, Pueblo. Thank you. Knapp, Illinois College. Thank you so much. Michelle Swanson's at the University of Michigan.
My pleasure.
That's what this little M is here, right? Doesn't mean Michelle, it means Michigan.
1,000 wins today on the gridiron.
Petra Levins at Washington University in St. Louis. Thank you, Petra.
Thank you.
Michael Schmidt is at the Medical University of South Carolina. Thank you, Michael.
Thank you, everyone.
I'm Vincent Racaniello. You can find me at microbe.tv. I'd like to thank the American Society for Microbiology for their support of TWiM. The organizers of this meeting for having us here to do this little panel. And Ray Ortega, our wonderful producer. Thank you. And Karen, thank you so much for joining the team. Couldn't do it without you. Thanks for listening, everyone. We'll see you next time on This Week in Microbiology. I have stickers. If you want stickers, come get them.